Problem 23 reads, Xavier and Sasha are swapping coins. Currently, Xavier has 3 coins and Sasha has 7 coins. During each turn, exactly 1 coin changes hands. If Xavier has C coins and Sasha has 10 minus C coins, then Xavier has a probability C over 10 of giving one of his coins to Sasha, and Sasha has probability 1 minus C over 10 of giving one of her coins to Xavier. Compute the probability that after 4 turns, Xavier and Sasha will both have 5 coins. So whenever I'm talking about something that I can visualize, I always try to draw at least a small picture out. So here is Xavier's pile, we'll call it X, and here is Sasha's pile, we'll call it S. Now, for Xavier and Sasha to at any point end up having 5 coins each, then 2 of the coins from Sasha's pile must somehow make their way over to Xavier's pile. So we know for 2 of these turns, the probability has to work out that Sasha is giving a coin to Xavier. But that's only 2 moves, and we need 4, and it shouldn't be too hard to see that the only way we can have 2 more turns elapse where Xavier and Sasha don't have their relative value of coins change after those 2 turns is if one of them gives 1 coin to the other, and then the other gives that coin straight back. So for this, we have 2 turns where Sasha gives a coin to Xavier. And for this part, we have 1 turn where Xavier gives a coin to Sasha, and 1 turn where Sasha gives a coin to Xavier. Obviously, not necessarily in that order. So we're trying to order 4 turns where 3 of these blanks we filled in with an S, and 1 of the blanks will be filled in with an X. And you should see that there's 4 ways to arrange that. We can either have the X in the first place, in the second place, in the third place, or in the fourth place. So we can just go case by case for each of those 4 cases and calculate the probability of each one. So to start, we know that if we start with Xavier giving the coin to Sasha, well, he has 3 coins, so there's a 3 out of 10 chance that he's going to give Sasha the first coin of the game. And then Sasha will end up with 8 coins, and she will give Xavier 3 coins, which has a probability of 8/10, and then 7/10, and then 6/10. Multiplying all this out, we're going to get 3 times 8 times 7 times 6 is 1,008 over 10,000. I'd also like to point out that while we could simplify this fraction, we're going to have to compute multiple other probabilities and then add them up at the end. And all of the fractions that we'll be multiplying together in our other cases are going to each end in 10, or each have a denominator of 10, and there will be 4 of them. So all of our results, if we don't simplify, will have a denominator of 10,000, which will make it easier for us to add up our 4 fractions later when we're done calculating these probabilities. So we're not going to simplify this fraction quite yet. For our second case, where Sasha gives Xavier 1 coin, Xavier gives that coin back, and then Sasha gives him 2 more, our probability is going to be 7 over 10 times 4 over 10 times 7 over 10 times 6 over 10, giving us 1,176 over 10,000. And then for our last 2 cases, both times Sasha gives Xavier 2 coins, so ending in them both having 5, and then it doesn't matter which one gives the coin to the other first. We just need to guarantee that whoever receives the coin that first time gives it back, and they're going to give it back with a probability 6 out of 10. So these last 2 calculations are the same, and the probability of either of these happening is 1,260 each out of 10,000. So now that we have all 4 of the probabilities of Xavier and Sasha ending with 5 coins each after 4 turns, we can add them up, which is going to give us our final answer. And it's going to add up to 4,704 over 10,000. And now, obviously, it is time to simplify because we need to give our answer in lowest terms. And once we simplify this fraction, we find that its simplest term form is 294 over 625, which is answer A on today's test. And there's our solution, and we're done.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.